Thank you so much for your introduction, your kind introduction. And ladies and gentlemen all over the world, I welcome you to this most beautiful lecture hall at the Technical University of Vienna with a wonderful view on the city. I'm an old woman, and for me, it is not easy to do without physical presence. I do not believe that virtual presence is in any way equivalent. However, we are all concerned presently about this terrible pandemic, so I have to play the game. As you know, the city I am in, has been hit by terrorist attack and is now returning to peace. And we are all concerned about the ongoing election. It's really a turbulent time, but let us nevertheless turn to our topic. When I was originally invited to give a lecture here, our hostess, who is a good friend of mine, said, Christiane, you can talk about anything you like. This is not easy for me. Eventually, however, I found out the motto of the conference, the outline of the conference. So then I said, I have to talk about this. So there will be no talk about philosophy today, or hardly any. It will be about software engineering, and I will take the approach that software engineers are in charge of their projects, and it will be up to them to decide to what extent they can use either conceptual modeling or machine learning as tools. That is my main point. Let us investigate this a little further. So this is from the outline of the conference. You can see it's a grand claim. The world is being reconstructed through software and data. Conceptual models seem mandatory, yeah? No, I mean, the big claim. They help us to develop images of possible future worlds. So 2 comments from me. I think the world is not being just reconstructed, it's also constructed. This is not a world sitting outside here and waiting for reconstruction and staying unchanged. There's a constant interleavement between this reconstruction and new construction. And we have so much software nowadays where we actually construct new worlds. That is my first comment. And the second one is, of course, they help us to develop images of possible future worlds in a specific way. It's like if they say, you see the world through your glasses, of course, if you are in the conceptual modeling communities, as you probably all are, or most, then you see the world in terms of structural, functional, and interactional models. Yeah, it is not the only way to see the world not even in computing. You can frame your model, your problems quite differently. Like, for example, you can think in functional terms, or you can think in object-oriented terms, etc. There are different ways of framing problems, and that's important for today. So the second excerpt I have from the outline relates to machine learning. So some AI proponents predict the end of conceptual modeling. So here my comment is, hail, here speaks the prophet. Yeah? In the long tradition of computing, we have been through many hypes, and the hypes always come up with grand claims of this kind. Yeah? It will be the end of, the age of, the beginning of, etc. So, however, that doesn't deny that, in fact, the actual approach at hand is useful, can be useful. So machine learning will enable automated software construction, both faster and at much lower costs. So I think we need to examine which parts of software construction and how, yeah? And what is positive and how can we relate to this? And as I said, I will place the software engineers in the center. Software engineers nowadays have one of the most responsible professions worldwide. Many of them are concerned with our safety, others with the working of our community, with the infrastructure and everything. It is certainly a fallacy to reduce the work of software engineers to producing code. That, I think, is behind part of false claims about automating software construction. We do not consider software engineers as code producers, but as consultants to their customers in software matters. I follow Peter Nauer, the great computer scientist, one of the great computer scientists of the earlier times in doing this. And I also draw on his paper from the 1980s where he described programming as theory building. It is the software engineers who relate the problem of the customers to the possible solutions with the aid of computers, and through their activities as a whole, develop an understanding of what the software should do and how it should be used. This can, in principle, not be automated. So the place of machine learning in the context of software engineering is that of a tool, yeah, like also conceptual modeling. And so what I'm talking about is the relation between software engineering and conceptual modeling on the other hand, on one hand, and software engineering and machine learning on the other hand. And in both cases, I can say there is a body of knowledge that we refer to as conceptual modeling, and it intersects with software engineering. There's also conceptual modeling outside software engineering. So we are interested in the intersection. And of course, there's a large part of software engineering that is outside conceptual modeling. There are different fields of application and there are different activities. So there are other software engineering methods. And similarly, you can now draw such a picture for machine learning, which is a newcomer in the field of software engineering. So you could say machine learning is mostly outside software engineering, but now pulls into software engineering. And we want to understand how this machine learning paradigm can usefully be applied. Yeah, that is our concern. And in this talk, I'm not going to be concerned with machine learning and software engineering as a whole, but specifically with the question, can machine learning make conceptual modeling obsolete? Yeah? Conceptual modeling has a specific place in software engineering, and could it be that there will be no more because machine learning will take over? Yeah? That is what I'm talking about today. So will it be the end of conceptual modeling? Conceptual modeling specifically is located in information systems design, and although none of us can give a precise definition of what an information system is or is not, we have an intuitive way of using this term. I could also say interactive application systems or web applications or whatever. We sort of know what we talk about. And the early phases of software development, of course, are requirements, analysis, specification, and architecture design. And it's in that sphere where conceptual modeling is located in software engineering. So this is the intersection of conceptual modeling and SE. And similarly, you can say, well, machine learning also has an agenda in SE, no doubt. But it doesn't make this agenda very clear yet. It comes with the big claim, yeah? I will do everything for you. I will replace 30% of you, etc. This kind of thing. So does it concern all types of systems? Does it concern the whole life cycle? I think not, but I think there might be useful applications. So we have this ML in intersection, the ML in SE. As it turns out, I have a son who is a senior software engineer in a major American software company. And I talked to him yesterday, mainly on the occasion of the elections, but I also told him about this talk. So he said, yeah, you know, I'm using an ML tool, very useful tool, surprisingly good tool, which is integrated in my IDE. And what it does is code completion, and it's amazing. So there is no doubt that software engineers start to appreciate machine learning tools in certain contexts. I will certainly not deny that. But can it supersede conceptual modeling? That is our question. So if we have that, can there be an intersection where actually machine learning takes over? That is our topic. So I would like to remind you to one of my famous, my most loved American sayings, which is, to him who has a hammer, the whole world seems as a nail. Yeah, wonderfully wise saying. And of course, all of us who propagate one method, one approach, no matter which, are in precisely this position. We go out looking for nails for our hammers. Yeah. I am not the exception, except of course that I'm old and wise now, and I have grown beyond my own approach. But it takes some time. You can observe very renowned computer scientists eventually growing out of their own approach. But as long as you are in your approach, you will be in this position. But the software engineers should not stick to the hammer in all cases. I mean, by the time they have a screw, they should not drive it in with the hammer, yeah? And by the time they need to do other things, they need to know other tools. This term tool awareness, which is also due to Peter Nauer, relates precisely this. Yeah? Software engineers are the ones who are responsible. They are responsible to their customers, and they are responsible for the quality of the software. And they need to assess SE approaches as tools, and not one approach, but several approaches. And they need to understand how to use a tool and to choose the tools they need for the task at hand, to tailor them and to combine them with other tools. Yeah? And in doing this, the objective is the overall process. It's no use to have a tool that improves one part of the process if the rest then gets more difficult to do. Yeah? And this is actually not only for machine learning, this is a very specific problem for many approaches. Like we have been through the formal specification time, and there was always this idea, if you do a formal specification, then your code will be better. But the rest of the process was not in alignment with this. Yeah? So eventually, this community withdrew a little bit from their grand claims. So what we need to do is to assess ML tools in IS design. So how does ML relate to human understanding and communication? Yeah? How does it support software construction? How does it facilitate change? Systems change in information systems happens all the time. We need to make experiments, and I'm happy when I looked for papers in preparing this lecture, I found a wonderful paper that maybe you all know. It's not new, but it relates just such an experiment. It was actually done in 2008. And the paper is called Investigating Statistical Machine Learning as a Tool for Software Development. Yeah, that's precisely the kind of thing that I'm advocating. Make such experiments and learning from them. So what do? They have made a comprehensive study consisting of 2 parts. They have interviewed 11 researchers, and the core part was a 5-hour study with 10 participants who were solving a realistic problem. And the task that they chose is, of course, very good for machine learning. It was to recognize handwritten digits. And these people were all educated in machine learning, and they had a tool set that facilitated the whole process of machine learning, and in particular, a special tool that supports statistical machine learning. So it was really an experiment designed for the best case, yeah, having developers who know their way well and know what they're doing. So what did they find? Somewhere in the introduction already, they have a little excerpt saying, a developer who cannot conceive of how to frame a problem as a matter of learning a function is encountering a barrier. Yeah. So I have to confess, I cannot conceive how to do that. And I presume that most people in the software engineering cannot conceive of how to do this. This is a new way of seeing the world. And the barrier will be a strong one. It will be maybe a matter of education. But should we educate only ourselves, perhaps not me, but the next generation? Or do we also need to educate our customers? I don't think they want to learn how to express, how to frame their problems in terms of machine learning. I don't think they will want to do that. So the second question is, are all problems conducive, yeah, to this kind of framing? And that is another understanding we need to develop. In the experiment, they wisely chose a problem that everybody understands needs pattern recognition and is conducive to adaptive systems. That is quite clear. But then are information system problems also of this kind? Yeah, and I doubt it. I very strongly doubt it. So there is this need for understanding problem affinity. We need to understand which types of problems are candidates for ML use. That will have to develop in the time to come. Now, the second related problem is that although supposedly this will all be automated, it is up to the developer to supply the so-called features. Yeah, it's the core of the whole approach is to have a function. Y is a function of x1 to xn, and the x1 to xn are known as features. And each feature should capture some useful aspect of the problem being modeled. This, you know, I'm an old timer. This sentence just opens an abyss, yeah? It should cover some useful aspect of the problem being modeled. Which aspect, how do you select the aspects, should they relate to each other? We all know that there are problems here. And then I see that the term modeling is being used. It's a new way of modeling, yeah? And it's a very, very different way of modeling. So the features need to be provided by the developer. It's a new way of modeling. That means we have to develop and teach criteria for feature selection. That is what software engineering is all about. Yeah? We have spent years developing criteria for architecture design. So now at a different level, we would have to do the same work again. And the core insight of the paper itself are the challenges of the ML process. The challenges of the ML process, although they were all specialists and although there was problem affinity, one, pursuing statistical ML as an iterative and exploratory process. Now, for me, that is the core of my teaching. Software development is an iterative, exploratory process. And now they transfer this philosophy to a non-software development part, yeah, which is not necessary in software development. I can do software development itself as an iterative exploratory process. But now again, I have a new level. Understanding the relationships between data and the behavior of algorithms. Completely new skill. It wouldn't occur to us as a problem. And evaluating the performance of statistical ML algorithms and techniques. So I must honestly say, if I were still active as a professor in software engineering, I would leave this particular approach to software engineering to my colleagues in the departments where software of this kind is being put in the center. I don't think that information systems are candidates. That is my conclusion. So we have new competencies to learn, new activities and new sources of error. Yeah? So it is, anybody who says it's just automating is cheating. And we need to train SE experts in machine learning. And it will be a big effort to get such experts. There will be some, no doubt. So returning to our question, how does ML relate to human understanding? Well, the score is not positive. There's this barrier. It's a new way of modeling. It is not intuitive for our customers. Yeah? We cannot go to the customer and say, well, statistically, with adaptation, the right client will get the right bill. Yeah, it's not feasible. How can they support software construction? Well, surely they can if they are integrated in interactive tools so that the software engineer can retain the responsibility and in interactive toolkits. And how can they facilitate change? Well, only if humans are in charge of design and architecture. And that is a non-trivial statement to make because it's a question of how do you combine components that rely on statistical machine learning with other components that do not rely on such things. It's a little bit like having the problems in structured programming where you want to have exceptions where the structured programming does not hold. Yeah, you will have to find patterns, how to embed such components and then use them safely. So I'm coming to my conclusion. The conclusion is that ML may well be useful in SE. In suitable application learning areas, for example, anything having to do with pattern matching and adaptive behavior. And in suitable activities, code completion is an example and re-engineering is another example, and there are more. But ML will not help us to develop images of possible future worlds. Remember, this was the claim of conceptual modeling. It cannot do this, yeah? It is not designed to do this. So the picture, will ML supersede conceptual modeling and software engineering? This question, I have to say, it won't. Yeah? No, thank you. This is the end of my lecture. Thank you for your attention.